Hello and welcome back to Swecodes. In this lesson, we'll solve Leetcode problem number 1323, maximum 69 number. We'll go step by step. First the problem, then intuition, examples, our thought process, 2 Java solutions, and finally complexity and pitfalls. We'll use simple data structures, just a character array or pure arithmetic, and a very small but powerful greedy insight. We're given a positive integer whose digits are only 6 and 9. We can change at most 1 digit. A 6 can become a 9, and a 9 can become a 6. Our goal is to return the maximum value we can get after performing at most 1 change. The constraints are tiny, up to 10 to the power of 4. So this is a thinking problem, not a brute force race. The key question, which single digit, if any, should we flip to get the biggest possible number? Think about place value. The leftmost digits matter far more than the rightmost ones. If you want to increase the number the most, you should look for the first 6 from the left and change it to a 9. That gives the largest possible gain in value. If there isn't any 6 at all, flipping a 9 to 6 would only make things worse. So in that case, we should do nothing. This is a classic greedy algorithm. Make the locally optimal choice, the first possible 6, because it guarantees the globally optimal result. Let's walk through an example 9669. We consider flipping each position once. Flip the first digit, 6669. Flip the second digit, 9969. Flip the third digit, 9699. Flip the fourth digit, 9666. The maximum is 9969. Notice how this matches our greedy rule. Flip the first 6 from the left. Next, 9996. There is no number 6 until the last position, so we flip that final 6 to 9 and get 9999. Again, the first 6 from the left, in this case the only one, is the right choice. For 9999, there's no number 6 at all. Any change would reduce the value. So the answer is the original number, 9999. Let's translate the intuition into steps. 1. Scan the digits left to right. 2. If we find a 6, we flip it to 9 and stop, because only 1 change is allowed and this is already the best place to change. 3. If we finish scanning and never saw a 6, we just return the original number. Why does this work? Flipping a 6 to 9 increases the number by exactly 3 times place value. The larger the place value, the larger the increase, so the earliest 6 gives the biggest gain. In our first approach, we'll use a string and a char. Simple, familiar data structures. The algorithm is greedy. Scan from left to right and flip the first 6. Steps. Convert the number to a string, then to a char array so we can edit in place. Loop from index 0. When we hit 6, set it to 9 and break. Convert back to an integer and return. Let's write the code together line by line. I'll define a class solution and a method maximum 69 number that returns an int. We start by converting the number to a string and then to a char, called digits. Next, I write a for loop from I equals 0 to the end. Inside I check, if digits I is 6, I set it to 9 and immediately break, because we're allowed only 1 change. Finally, I build a new string from the modified array, parse it back to an int, and return that value. This follows our greedy plan exactly, and uses a simple character array as our data structure. In the second approach, we won't use strings at all, just integers and place value arithmetic. Data structures are minimal, a few integer variables. The algorithm is still greedy, but implemented numerically. We examine digits from right to left using %10 and /10. We remember the most significant position where we saw a 6. If at the end we found such a position idx, we return number plus 3 times 10 idx. Otherwise, we return number unchanged. I keep a copy n equals number, a position counter POS starting at 0 for the ones place, and idx equals -1 to mean no number 6 found yet. While n greater than 0, I take d equals n% to get the current digit, and if it's 6, I store its position in idx. Notice, as I continue dividing n/equals 10 and incrementing POS, I'll eventually overwrite idx with more significant SAXS. So idx ends up as the most significant SAXS position. At the end, if idx equals -1, I return number plus 3 times 10 idx, which is exactly the bump from turning a 6 into a 9. Otherwise, just return number. This version uses O1 extra space and shows the place value reasoning explicitly. Now let's look at the complexity analysis. Let D be the number of digits. Here, at most 5. Time, both approaches are OD. A single pass through the digits. Space. Approach 1, OD, because we create a char and a new string. Approach 2, O1, only a few integers. Given the small constraint, both are instantaneous. Choose clarity first. Both are perfectly acceptable in interviews. Test the edges. All 9s like 9, 99, 99, 99 answer is unchanged. Leading 6 like 6, 69, 66, 99, flipping that first 6 gives the largest gain. Single-digit cases, 6999. Mixed patterns, 9669, 6969, 9996. Common mistakes, flipping more than one digit, flipping the last 6 instead of the first, or converting back incorrectly. Here we're safe from overflow due to the small bounds. To maximize the number with at most one change, simply flip the first 6 from the left to 9. If there isn't any 6, don't change anything. We saw 2 neat Java solutions. String/char array approach, very readable. Arithmetic approach, no strings, O1 space. Both are linear in the number of digits. This is a small but classic greedy problem, and the place value reasoning is the key takeaway.